Things are looking great so far for an on-time launch today from our private orbital range Rocket Lab Launch Complex 1 on New Zealand's eastern shore. Now, you have seen the launch range and inside our mission and control centres. Now it is time to get you acquainted with the Electron rocket lifting off the pad today. And as you will have seen earlier in the show, we are taking an unconventional path to the moon, and that is because Electron is an unconventional rocket, the first of its kind in many ways, and one of the smallest orbital rockets in history to attempt to launch a spacecraft to lunar orbit. So here's a little bit more on Electron.
A small launcher dedicated for small satellites, Electron was the first of its kind to reach orbit when it first took to the skies in 2017, opening up access to space for small satellite operators. Today, it is the second most frequently launched U.S. rocket annually. More than 140 satellites have found their home in space across more than 24 Electron missions launched from Rocket Lab Launch Complex 1, the world's first and only private orbital spaceport. Designed, manufactured, and launched by Rocket Lab, Electron is a two-stage launch vehicle powered by liquid oxygen and rocket-grade kerosene. Much of its structures are made of advanced carbon composite material, including its propellant tanks, which is what gives Electron its sleek black look. The rocket is powered by 10 Rutherford engines, 9 at the bottom of the first stage, and a 10th space-optimized engine to power the second stage to orbit. The Rutherford engine is the world's first to use an electric pump feed cycle for orbital space travel, making use of electric motors and batteries to drive its propellant pumps. It's also 3D printed using additive manufacturing processes. Electron is also equipped with a third upper stage that serves as in-space propulsion to deploy payloads to orbit. In its most advanced form, this stage is called Photon, a spacecraft bus to support small satellite missions even beyond Earth orbit. It's to this structure that the CAPSTONE satellite is attached, ready to be carried on its way to its lunar destination in near rectilinear halo orbit.
T-minus 5 minutes and 30 seconds on the clock, and from here the launch team will move on to some of the final milestones and checks of Electron, Photon and CAPSTONE before liftoff. The mission will launch from Pad B today at Launch Complex 1, where we have 2 orbital launch pads within our private spaceport dedicated for Electron launches. Now, Rocket Lab launches typically deploy spacecrafts to orbits between 500 and 1,200 kilometers altitude above Earth's surface. But this time, as you'll know, Electron and our upper stage Photon will send the CAPSTONE spacecraft a little bit further than usual, some 1.3 million kilometers further. Around 9 minutes after liftoff, Electron's second stage will separate from Photon, placing the spacecraft bus and its CAPSTONE payload into an initial low Earth orbit of just 165 kilometers. Now, from this initial parking orbit, Photon's Hypercurie engine will perform a series of orbit-raising maneuvers over 5 days to stretch its orbit into a prominent ellipse around Earth. Now, 6 days after launch, Hypercurie will ignite one final time, accelerating Photon to allow it to escape low Earth orbit and set CAPSTONE on a course for the moon. From there, CAPSTONE's journey to NRHO is expected to take around 4 months, with the CubeSat's team at Advanced Space's Mission Operations Center commanding the spacecraft to fire its thrusters to adjust its course accordingly. Now, if we are looking back at the pad camera now, we can see that the rocket's strong back has retracted and has moved into the launch position. This launch platform structure is what holds the umbilical lines, providing power to the rocket, which will fall away as Electron lifts off the pad. You can see Electron's icy white stripes on the outside of the rocket there too. Those are because of the super cold liquid oxygen propellant on the inside of the rocket, which freezes water on the outside, causing it to form those distinctive icy areas along the rocket's black carbon composite body. Now, our last weather update also confirmed that the wind speed at T0 is expected to be good for launch, further minimizing the weather risk to today's mission. Now, as we get closer to the countdown, it is worth pointing out what kind of views to expect from launch today. As always, we'll be bringing you the live views you see on your screen from various cameras at the pad and at range control. However, for this mission, we won't have the typical onboard vehicle cameras you might be familiar with for Electron launches, and that is because this mission has extensive telemetry requirements. So to reduce the load on systems and operators, we've streamlined the mission down to essential systems only. Now, while we won't have those live vehicle feeds to show you, we will be broadcasting mission data and animations so you can keep up with the launch progress throughout the ascent. And now we are coming up to a critical juncture in the lead up to launch, the switch to the countdown auto sequence. The team are tracking no issues with the launch vehicle, Capstone and Photon remain healthy, and the weather is looking good. So at T-minus 2 minutes, very shortly, that autonomous flight computer on Electron will take over the launch countdown, followed by the call that LOX loading is complete on Electron. Then at T-minus 1 minute, we can expect confirmation that the vehicle's first and second stages are pressurized for launch. So, followed by that will be the iconic final countdown to liftoff at T-minus 10 seconds and engine ignition at T-minus 3 seconds. We'll hand over now to Mission Control and listen into those calls to launch.
Launch vehicle is fully on internal power.
Lunar Photon is on internal power.
LOX load complete. LOX system in recirculation. All helium anti-gathering disabled.
Stage 1 and Stage 2 addressed.
High flow engine purge enabled. Water deluge activated.
T-minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, lift up.
HVB discharge now.
Stage 1 propulsion is nominal.
Entering burnout detect mode.
Crank ship on 1.
At T plus 1 minute and Electron is in the air and onward to the moon for the Capstone mission. That rocket is soaring through this nighttime sky, now past 14 kilometers in altitude in these past few moments. Now things look to be continuing nominally, which means that shortly Electron will come up against max Q, or maximum dynamic pressure. Now this is the moment when Electron will experience its most amount of mechanical stress as it travels through the atmosphere. And I can confirm from Mission Control that we have had max Q confirmed, so that was a successful pass through that milestone, and Electron is onward to low Earth orbit. So propulsion appears nominal on that first stage, and the Photon lunar upper stage and CAPSTONE spacecraft remain healthy inside the rocket's fairing. We are coming up soon on 3 events in the launch timeline that will occur in very short succession. So soon, the 9 Rutherford engines powering Electron right now will diminish their power and then shut off completely. That command is signaled by the rocket's flight computer and then called across mission control comms as MECO, or main engine cutoff. Now, once that action is complete, Electron will separate its first and second stages. The main booster will continue to slow and remain behind while the second stage carries on with the mission with the ignition of its single Rutherford engine. And we have had MECO confirmed and will be coming up soon on the fairing separation for the mission. So just to confirm from Mission Control Comms, we have had MECO and second stage separation, and it's carrying on now, as you can see in that animation. So soon we will be coming up to the fairing separation of this mission. That is the jettison of the fairing halves, or the rocket's nose cone that sits on top of the second stage. So now that Electron is well past the Kármán line, we don't need that fairing. It served its purpose to protect the payload and the Photon upper stage during the launch through Earth's atmosphere. So again, that fairing will separate shortly in preparation for the final stage separation between the second stage and Photon.
Separation.
So there we go. We heard it on comms. We have had fairing separation on that second stage. And so there's confirmation that mission is continuing as it should, with CAPSTONE and the Photon lunar upper stage now exposed to space and no longer needing that protection through Earth's atmosphere. Now, it's very exciting to see this mission up and in the air. And if you have just joined us, we have had a great start to today's journey to the moon. We have successfully cleared the pad at Launch Complex 1 just a few moments ago, and we are now well on our way to space, having completed that first successful pass through Max Q, main engine cutoff, stage separation, and fairing jettison to reach this point now in the mission. Now, Electron's second stage remains attached to the Photon lunar upper stage carrying CAPSTONE, providing it with that assist to the mission's parking orbit at 165 kilometers above Earth. The rocket's second stage is moving along nicely on its continued ascent, now traveling at a very fast speed of more than 9,000 kilometers an hour. Soon, the second stage on the Electron rocket, which is powered by our vacuum-optimized Rutherford engine, soon the batteries on that engine will need to be swapped out. Now, this is a unique aspect of our 3D printed engines because it's not many engines that are powered by batteries in the first place. In fact, the Rutherford became the first rocket engine in the world to reach space using an electric pump bead cycle when it was first launched all those years ago. Now, how it works is that we keep the engine firing all the way to orbit with the batteries that are powering that engine. But like all batteries do, these ones get depleted of power and we'll need to swap them out with a new set to keep the system running. We call that a battery hot swap, and that moment is coming up shortly. We will hopefully hear that on Mission Control Comms.
Stage 2 is starting to throttle down. Stage 2 guidance remains nominal, 200 seconds remaining.
If we take a look at the graphics on the right-hand side of our screen, we can see the measurements for the propellant on Electron. So on your left, you have the kerosene propellant and the level of the tanks that it is now at. So we're at 45% and counting, sitting at a nice and warm 8 degrees in temperature. And that is very warm compared to the liquid oxygen temperature, our other propellant. So that is sitting at a nice and chilly minus 178 degrees with 40% or so propellant left.
Hot swap.
And there we have the call
Stage
that
2
battery
propulsion
hot
is
swap
holding
on the
nominal.
second stage was successful. Now, next we should expect to hear one of our operators in Mission Control call out that Electron is orbital. indicating that the rocket is in the right place ahead of stage separation. So SECO, the acronym for second engine cutoff, and the subsequent stage separation follow relatively the same procedure as main engine cutoff, where the Rutherford engine on the second stage will shut off ahead of the final separation of the vehicle between the second stage and the Photon lunar upper stage. There will be a bit of a gap between that final separation and the first hypercurie burn, as this stage separation places the Photon lunar upper stage in an elliptical orbit of Earth first. Now, a reminder that 165 low Earth orbit is just the first orbital phase for this CAPSTONE mission, with Photon and CAPSTONE's orbit continuously raised higher and higher over the next few days, with a series of engine burns on the upper stage. I'll go into more detail about Photon's phasing orbits and CAPSTONE's path to the moon shortly, once Electron has completed SECO and stage separation. Let's listen into mission control comms.
Entering burnout detect mode.
So a quick check on the speed and altitude of this mission. We are traveling at more than 23,000 kilometers an hour. And while on the right you can see the altitude is at 175 kilometers, what goes up must come down, and we will lower ourselves into that 165 kilometer parking orbit very soon.
SECO confirmed.
So with the Rutherford engine cooling down, that tells us that second engine cutoff was successful on Electron's second stage. And the Photon lunar upper stage has now departed into its low Earth orbit with the moon-bound CAPSTONE spacecraft on board. Now, as a reminder from here, Photon is in charge of the mission. With its relightable hypercurie engine, Photon will begin maneuvering into a parking orbit just above substantial atmospheric drag, but below the Van Allen radiation belts. It is the perfect, stable platform from which to prepare for lunar departure. Now, once Photon is in the correct orbital alignment, the hypercurie engine will ignite again, performing a burn to lift the highest point of Photon's orbit, the apogee. Now, as it gains altitude and also loses velocity, and so what goes up comes back down as Earth's gravity pulls it back towards the planet. When it reaches the lowest point, or perigee, once again Photon's hypercurie engine ignites to increase velocity and raise its apogee higher. So if you've ever been on a swing set, swung to the top, came back down, and then kicked your legs out to throw your weight forward to reach even higher on the next swing, then you've followed similar principles to what our Photon upper stage will be doing in space. Now, as these phasing orbits get bigger, they take longer to complete. The first will only take around 90 minutes, while the last one will take around 15 hours. Then on the final phasing pass, Photon will ignite hypercurie for a precision translunar injection burn, accelerating the upper stage and CAPSTONE to a top speed of nearly 11 kilometers per second, fast enough to break free of low Earth orbit on its way to the moon. The speed Photon is traveling at this point will shoot it well past the moon's orbit and to the edge of the Earth-Moon system on a transfer orbit. Lined up with the sun and using its gravitational pull to shape Photon's orbit to match speed with the moon, CAPSTONE will then be deployed and carry on the mission solo.